Today we are looking at how a MOSFET works. Good day everyone and welcome to my channel. Let's take a quick look at the physical MOSFET itself. This particular one is an IRF Z44. This one I salvaged out of an old audio amplifier, but you get them everywhere. Let's draw a small circuit diagram quickly to dive into some more detail. Now we can see on the circuit that we are busy drawing, I've got the MOSFET there already. It is marked gate, drain, source as the output pins. Your gate is your positive signal in, your drain is your positive for your load, and your source just as your earth or your negative for your power supply. Now we will go ahead and add the extra bits and pieces of the circuit. We'll just quickly go and draw a wire from the gate and from the source, and we'll just mark this as 12 volt. When you apply power to the gate, you allow current to flow through the drain and source, just like this. This in turn will complete your circuit. Let's quickly finish off drawing the rest of the circuit. You can see from the source we are going to add an earth, which is negative in this case. And then from the drain, this will go into our load. Let's just say this is a little light. And then from the light, it will go straight to the power source. It can be either a battery or a bench power supply. So now when you apply power to your gate, you complete the circuit between drain and source, allowing your load to switch on. But the problem is, now we need to switch it off again. And because the gate is electrically charged, it will not switch off. So, to solve this problem, we will take the gate and the source, and we will add a very small resistor between them. Usually a 10 kilo ohm is more than enough. But if you're going to be using it to switch higher frequencies, you might have to adjust the resistor. But usually for all sorts of applications, 10 kilo ohms normally works quite well. You can see there it's been added. And now what will happen, as soon as you apply power to the gate, that little resistor will bleed all the power off, allowing your MOSFET to turn off completely. Now we will do a real world demonstration. We're just going to go ahead and take the MOSFET and bend the legs out of the way. This will make it easier to install little odds and pieces in a moment. Just going to grab some wire. You can see that's a black wire, which is normally in a DC circuit. That means negative, going around the source of the MOSFET. Then we will go ahead and grab our LED. We will take the negative of the LED and strap that to the drain. And the reason we are doing the negative of the LED onto the drain is because you have negative coming from the source through the drain into your LED, and then your positive of your LED will just go straight to the power supply. Just like this. You can see there, it doesn't quite line up, but you can see the basic idea of what's happening. Now we are ready to do a short demonstration. Just off camera, I'm going to grab my bench power supply. Positive is going to go to the positive of my LED. Negative to the negative of the MOSFET, or source, if you will. On a note, the metal tab on the physical MOSFET itself is actually drain as well. It is directly connected. You can see there when I touch the gate to the drain, it switches on. Gate to source, switches off. Gate to drain, switches on. And that is basically how it works. But remember, I spoke of that little resistor that has to bleed the current from the gate out to the source. Otherwise your gate will just stay electrically charged. You can see if I touch the positive of the power supply, the LED goes brighter. That's because you get a more powerful DC supply going into the gate, which in turn reduces the resistance of the actual MOSFET itself when it switches on. That's why 12 volt is the ideal voltage, because that is when the MOSFET is fully switched on and doesn't just act like a big resistor. I hope you guys have enjoyed this tutorial. Please do let me know in the comments if you would like me to show you how anything else works, or if you'd like more detail of this particular unit itself. But anyways, you guys take care, and we'll check you in the next video. Cheers.